Welcome to the Masters of Reliability webinar series, How to Build Your Underground Asset Management Program, Reducing Risk and Improving Underground Cable Reliability. My name is Chrissy, and I'll be your moderator for today's session. At any time, we encourage you to submit your questions into the chat window, and we will address them during our Q&A portion of the webinar. The presentation will be recorded and will be made available to you on demand. I will now hand it over to Chris Sams, Vice President of Sales at Novinium, to introduce today's topic.
Thank you, Chrissy, and good morning or good afternoon, and welcome to our guests today. For those of you who may not be familiar with Novinium or haven't talked with us in a while, you may ask, what does Novinium do these days? Well, simply put, we champion ways to keep power flowing to those who depend on it. How do we do that? Well, first of all, we help utilities extend the life of their underground power cables. And you can see that here on the left with a section of medium voltage power cable. And you can see that we inject fluid into the conductor that actually restores the dielectric strength of the insulation and brings the cable back to a like-new condition, extending the life for up to 40 years. That's one way that we champion the ways to keep power flowing to our customers. And another way is that we help utilities to prevent manhole explosions. And we've launched a new product called the Prevent Manhole Explosion Prevention System that is helping utilities to predict and prevent manhole explosions before they happen. But today, we're really going to be focused on the asset management strategy component of our business, and that's related to the underground power cables on the left. Before we begin, let's start with a trivia question. This is going to require some audience participation. So the question number one is, it's a Novinium trivia question, and the question is, when did we start rejuvenating power cables? And there are four potential choices. The first is A, 1986, B, 1991, C, 2003, or D, 2015. So go ahead and make your selections now. And Chrissy is logging those right now. And Chrissy, just let us know when you want to publish the results of the survey.
All right, I've launched the poll. We have a few more people voting. Just a few more seconds. Okay, and I'll be closing the poll.
Well, we've got some bright people on this webinar today. 73% of you said 1986, and you would be right. Novinium actually has a 32-year track record working with hundreds of utilities, from small, medium-sized cooperatives and municipalities with, say, 5,000 electrical meters, to even the largest investor-owned utilities with greater than 5 million electrical meters or ratepayers. And so we've got a long track record of rejuvenating power cables. Most recently, I can share this with our folks who are attending the webinar. We're being engaged by circuit owners to perform what we call full turnkey cable rejuvenation. And this is really where the circuit owner wants to rehabilitate an entire circuit or a subdivision or a city with the most cost-effective, low-impact, and environmentally sustainable technology. So what the circuit owner does is they'll provide us with maps, and we will rejuvenate or inject. We'll rejuvenate first, and of course that's at a fraction of the cost of replacement. It's much faster, and it essentially recycles the cable in the ground. And then any cable that we were not able to inject, either because there were too many splices or perhaps neutral corrosion, we'll come behind and we'll actually replace that with new cable. And then at the end of the project, we'll return completed maps to the circuit owner, and the entire system's been improved and is ready for the next 40 years of service. So the question is, why do utilities rely on rejuvenation? Well, here are some of the main reasons that we hear from our customers, because it extends the life for 40 more years, and they really appreciate the warranty that we provide with it. It preserves capital dollars. Because we are only popping open the transformers and then injecting the cable, and we're not bringing in boring rigs and drilling rigs, it's a very low impact to your customers. You're essentially recycling that cable in situ or in the ground, and so it's environmentally sustainable, environmentally friendly, and of course it's much faster than replacement. So if you're interested in learning more, please reach out to us through our website or send a chat to Chrissy in this webinar. But let's get to the core of our meeting today. So we hear from circuit owners all over the US and Canada that they're experiencing increasing faults over their aging cross-linked polyethylene cables, their EPR rubber cables that were installed 40 or 50 years ago. And so there's an increasing concern over how to properly address this problem. So we invited two guest speakers today who are both experts in the area of asset management strategy. First, Darren Johnson, who is the president and director of the asset management practice at BIS Consulting. And secondly, Kevin Courtney, who's CIO and managing director of the UMS Group. Darren has worked with utilities throughout North America for the past 20 years, helping them justify and optimize their asset management plans to rehabilitate their aging assets. His cable assessments have been used to justify millions of dollars of funding for cable rehabilitation for regulators and utility executives. At UMS Group, Kevin Courtney is a 35-year industry leader in information technology solutions. His tools deliver actionable business insights for better business decision-making process across electrical utility industry. So their combined experience will hopefully spark ideas for you today to build an asset management program and to compare different intervention options for aging underground cable and help you justify the right level of spending to improve your cable reliability at your utility. So welcome, Darren and Kevin, and I now turn the presentation over to you, Darren.
Thank you, Chris, and thanks to all of you for allowing us to be with you today and talk with you. I hope this will be interesting and productive. So my portion of this presentation is to talk about underground cable in the context of asset management and to give you sort of a conceptual view of how asset management approaches decision-making with respect to cable rejuvenation or replacement. And then Kevin will show you an example of an application that actually does that analysis to show you what it looks like in anger. So Chris touched on this already, but utilities are widely facing what I call the underground cable problem. So this will be familiar to all of you. There's a lot of cable that was installed in the late 60s and 70s. Some of the older vintages, the XLPE cables especially, are suspect. And so what we're seeing are increasing rates of failure from the underground cable populations, which everybody kind of recognizes, I'm sure you do too, sort of recognizes as a problem, something that needs to be addressed. And as if that weren't enough, there's increasing pressure from regulators and boards and utility executives. They're demanding facts, and they don't want arm waving. They want to understand what are the cost-benefit trade-offs for cable interventions relative to the other spending that we might do. So that kind of puts you as a utility asset manager in now what position? What am I supposed to do? So the purpose of this is to talk about what would the asset management approach be. I like to describe asset management as solving this fundamental problem that a lot of utilities face. So there's a whole bunch of information and expertise and knowledge that's contained in the heads of the people who have been working there for a long time. And they have a pretty good idea about what needs to be done, but aren't always able to explain the need for spending in a way that resonates with the non-technical stakeholders, the finance groups or the regulatory groups. And so there's this tension between the pocket protector people and the green eye shades people. And the purpose of asset management is to bridge this gap. It's a way of translating technical understanding about assets into economics and cost benefit and risk assessment that resonate with finance people and rate makers. And so it's really about demonstrating value. Why is this good? You say that we need to spend this money. What are the improvements going to be? And also prove it to me. Show me. What are the assumptions that you're making? What data are you drawing from to make these decisions? So the fundamental tenets, the primary tenets of asset management are customer focus. We want to make decisions that make our customers better off. Data driven, meaning that we want to use hard data where we've got it available to us. And we want to have a repeatable, defensible, and challengeable process that's open for anybody to look at, so our assumptions can be improved over time and we can be transparent with our stakeholders. So this is the first poll question, or second poll question rather, sorry. The question is, does your utility have a person or group dedicated to asset management? Yes or no?
Okay, I'm going to go ahead and launch that poll. Please answer yes or no. I'll give everyone a few more seconds to answer this. And I'll be closing the poll. So it looks like we're 50-50 exactly.
Okay. Interesting. Okay. And then we have another follow-up poll question. Has your board or regulator reviewed your cable program? Has somebody taken a look at it and applied some pressure to the spending that you want to do? Again, yes or no?
And I'm watching this poll as well. Please answer yes or no. I'll give everyone a few more seconds to answer. All right, and I'll be closing the poll. It looks like we are 38% for yes and 63% for no.
So again, pretty close to 50-50. I think some of you are probably lucky, and maybe you're on borrowed time. Maybe it feels like that to you too, and you sense that pressure may be coming. But that's definitely been the trend, is that the say-so of the utility in and of itself isn't necessarily enough to justify spending. So, so let's talk about what have been the conventional approaches in the past. These are what utilities did to make decisions about replacing almost all their aging infrastructure, not just cables, but certainly cables too, is what I would call a technical approach. And they usually fell into two categories. One was a reactive approach to cable replacement. This would be something like that three strikes and you're out approach that you see a lot. So once a cable has faulted 3 times, it gets replaced. And then the other extreme is a more proactive approach, where you kind of start at the northwest corner of your utility and work your way across, replacing sort of all of the old style underground cable. The problem with each of these is you haven't done anything explicitly about what's the trade-off between spending money on cables and risk. So the asset management approach is to turn this into an economic question and say, what we really want to do when we make a decision to replace a segment of cable is we want to optimize the trade-off between increasing risk of failure as the cable ages and the cost of intervening. Now, I'm talking here right now just about replacement because it's simpler. And from a life cycle cost perspective, that's the place to start. But there are, as we know, there are other options for cables besides just replacement. We're just going to start here. So this orange curve, this is the risk of the existing cable as it gets older. It starts low, and as the cable ages, it becomes more and more likely to fail. And the costs associated with that failure create risk. And what you're looking for is, what is the threshold, what is the timing at which that risk will cross a threshold where it would be cheaper for you to replace the cable. So we're looking for, when does the risk cross this blue dotted line, which is the life cycle cost of a new asset. So in this example right here, this particular cable would have 10 or 15 or whatever number of years of remaining economic life. Doesn't mean it's going to fail in that period of time. It doesn't mean that it won't fail in that period of time. It just means that after that period of time, the risk will be such that a replacement or other intervention will be justified. Okay, so this is sort of a cartoon of the asset management approach. We want to be able to do this calculation for real. We're going to need to have some information on hand. So what do we need? Well, you need to know about the probability of failure. How likely is the cable to fail as it gets older? And you need to know what happens if it fails. So it's going to be things like, what is the cost to repair it? What are the customer effects? What are potential safety effects and so forth? And these two together comprise risk. Probability times consequences is risk. And so that's that orange curve we were looking at before. And then you need to know, what are your intervention options? What could I do to change risk? The most obvious examples are, you could replace the cable, or you could rejuvenate the cable. And either of those is going to reduce the probability of failure and reduce the risk. So those are things that you might be interested in doing. A word about this data. I'm going to talk a little bit more about what this data is going to look like. But when you're starting out in asset management and thinking about applying asset management approaches, there's this temptation to wait until you have perfect data on hand or good data on hand. And in my opinion, that's the wrong approach, that you don't get a vacation from making spending decisions for a year or 2 years while you get the data into the form that you'd like it. You have to make decisions now. So it's really important to kind of develop an attitude of making do with what you've got. I want to encourage you to look at it that way. Okay, so let's dig into these just a little bit, each of these. So failure probability. I'm going to map out for you kind of 3 tiers of what failure probability information might look like, sort of the order of preference. So the first tier is where I don't have any failure data that I can work with. All I have is the judgment of my subject matter experts. So I get those guys together in a room and I say, hey, how long do cables last? How long do old XLPE cables last? And they might say something like, well, a typical segment might have a mean time to failure of 40 years. And believe it or not, that alone is enough to make a reasonable guess about what the bathtub curve, that failure probability curve for underground cable might look like. The next tier up would be something based on SME judgment, but calibrated with maybe your near-term failure data. So this would look something like this. We asked the subject matter experts and they told us 40-year mean time to failure. That would imply that we should have had 400 failures last year. So you could calculate that number. And what if we only had 300? Well, that means that your curve was a little aggressive, and so you can calibrate it. You can scale it down by a factor of 3/4, and now you've got a calibrated failure probability curve. And of course, the gold standard would be a curve based on detailed failure history, where you can actually do some regression. And some utilities have data that they can work with to do this kind of work, and some don't. I would say that in my experience, most utilities don't have detailed failure history, and so they're working with some combination of judgment and near-term failure rates that they do know. Okay, the next input that we mentioned was consequences of failure. And this graph is just to give you a conceptual idea of what it is that we're trying to capture with consequences. So everybody knows about the $3,000 or $5,000 it takes to dig in and splice the cable. But if you ask yourself, when a cable fails, what am I worried about? It's not that $5,000, it's the outages. You got people out there scrambling to restore service because you're concerned about customers who have lost power. And so that's the biggest deal. So what you'd like to do, you can sort of imagine this, is get somebody with a clipboard and say, all right, we've got this feeder here, and it's possible there'll be a failure on the trunk that'll interrupt everybody for 2 hours. What would it be worth to you to avoid that outage? And your industrial customers would give you one number, and your residential customers would give you some other number, and you could say, great, I'll add those all up, and those will be my estimate of the consequence of that failure. This is an estimate of their willingness to pay to avoid an outage. And of course, you're never going to actually get this information this way. It's almost impossible to just go around and ask people this question and get an answer that you can work with. This is conceptually what you're after, but in order to get actual data, there are a few sources that utilities often turn to. I'm not going to go into these in a lot of detail, but I just wanted to mention some utilities have a value model that they use for prioritizing investments. So this will be, the executives will get together and they'll say, here's how we value reliability versus financial performance, and here's how we value environmental performance versus dollars, and so forth. And so they'll give you some standard conversion rates that you can use. Some utilities have that. I think for most of us, the best place to look is the ICE calculator, and maybe you're familiar with that. If you aren't, you should go look it up. I've given the the link down here below, and you can just type in icecalculator.com. Please wait until after the presentation here. But that'll give you some information about estimated customer outage costs in your area based on surveys that have been commissioned by the Department of Energy. And it's a good source that you can turn to for estimating customer outage costs. Then the other thing you'll need to know for a given cable is who does it serve? So, and what happens when it fails. So I've shown here two loops, two taps rather. One of them is a radial tap, so you can see on the top one out there on the end, there's a switch. And so if it faults, the outage duration is going to be relatively short. And the one below, it's a radial tap. There's no switch on the end. And so the relevance of this is that if I have a cable fault, those customers are going to see different effects based on the configuration of the system. And so you want to take cognizance of that when you're thinking about consequences of failure. All right, so now we've thought about consequences of failure and we've thought about probability of failure. And so in principle, we could plot each of our cable segments into this risk matrix. And I'm sure everybody has seen examples of this. It's very common in asset management. And I think it's a big step forward from where people are when they start. This is great information. Unfortunately, it doesn't answer the most important question. And the most important question is, there it is, so what? So I know what the risk is. What should I do about it? And to answer that question, we need to think back to that economic model that we were looking at before and ask, what is the trade-off between that risk and the money that we would spend to mitigate it? So you remember, we had one option was to replace the cable. And in this example here, the risk is rising, and you'd replace this cable where the curves cross at about age 30. Anytime before age 30, the risk will be lower than the cost of a new cable. And anytime after age 30, the risk will be higher than the cost of a new cable. So as long as the risk is lower, I want to leave it in place. And once it's higher, then I want to replace it, if replacement is my only option. Of course, the problem with replacement is that it's really expensive. And so you can't really mitigate very much risk per dollar if your only option is to go around replacing cables. So you also want to consider cable rejuvenation. So when you rejuvenate a cable, you can see in the graph there what's happened is we've added this dotted risk curve. So we come along here till age 20, and then we inject the cable, and what happens is we create a little notch in the risk curve. We lower the risk for a few years, 40 years maybe, until we have to come back and replace the cable or intervene again. And that gives us two benefits. One benefit is that we get to have lower risk for the next 40 years because we've addressed the cable. And the other benefit is we get to delay the high cost of cable replacement for 40 years or some number like that. And so your asset management approach should consider those trade-offs between capital spending and avoided risk and delaying of capital expenditures when you're coming up time to make a decision about what your strategy is going to be. So if we go back to our risk matrix, this is the same one we were looking at before, and the only difference is that I've put a red dot over the assets that are at end of life. So end of life means it's time to intervene, either to replace the cable or to inject it in this case. This is if you notice, the axes are both logarithmic, so it's not quite as much of the population is at end of life as it might look like. But as you'd expect, the red dots are clustered around the upper right-hand part, the high-risk cables. It's where it's what you'd expect. Those would be the highest priority. And so this is an example taken from a real utility. What we found was that where injection was feasible, that it was almost always preferable to replacement. And of course, not all the cables, even not all the old XLPE cables, are at end of life. There's a lot of them that you can cost effectively wait and allow them to age some more, to postpone replacement cost effectively. The program tends to be focused in the commercial and industrial areas where the customer outage costs are higher, and also on the getaways and the trunks where you're going to interrupt entire feeders and not just a subdivision. And there was pretty much no spending in this example, and this is typical, pretty much no spending on modern cables. You put a new cable in the ground in a conduit, it's going to last a really long time probably. At least it looks that way. So that's an example of what the results will look like when you take this approach. So with that, I'm going to turn it over to Kevin to show you an example of what a tool might look like to perform this sort of an analysis.
Great. Can everybody hear me? Okay. Well, Darren, thank you so much for that great setup, and to all my colleagues over at Novinium, thank you so much for giving us this opportunity to talk to you today. What I'm going to do after that basic understanding that Darren has given about asset management strategies is to take you through a tool which we call AERO, which is the Asset Economic Risk Optimization Model. And so it's a software tool, and in fact, it's been built based upon many consulting assignments from the past where things were done with a little bit less rigor and more Microsoft Excel activities. Its focus is to answer several questions, and the most important question is that so what question that Darren talked about earlier, which is to determine the optimal time to either replace or refurbish each segment of your underground cable based upon an economic basis. So it uses all of the data that Darren talked about before. It takes data from underground cable, sometimes it takes condition data, sometimes it will consider costs, such as maintenance and rejuvenation and replacement. If we can establish what the consequences of failure are, then we'll use that. And we'll try to use industry industry standards, all the things that he talked about a little earlier. I'll digress just for a moment. When we talk about Arrow, today we're talking about Arrow for underground cable, but Arrow has kind of a broader life cycle. Not only will it help you with your underground cable, but it can do the same type of work for transformers and circuit breakers and relay systems and other types of assets that your utility might have. So exactly what is it that Arrow does for you? Well, the three major areas that I wanted to talk about today is, number one, it answers the question, right? It develops the spending plan that is that allows you to look at current spend and then out into the future. Just as important as building the plan and identifying what you should be spending, it provides a documentary record of all of the factors that went into making a decision about each and every segment. So we'll show you all the documentation that it supports behind the scenes. And then finally, because we have this really fabulous data set, we have Arrow can operate like a decision support analysis tool. It allows you to kind of dig in, pose a hypothesis, discover information, discover characteristics in your own data that may not have been obvious before, or it might it provides you with evidence on those hunches that you've had. So let's talk about the value proposition. So what value does it deliver? Well, Darren's already shown you that it provides really a best practice, a repeatable data-driven methodology. It provides you with a very defensible position for making spending decisions that has passed muster with regulators and management and boards of directors. And it facilitates those discussions when they actually come up with both the regulators and other key stakeholders within your organization. So Arrow provides you with the plan, and then it provides you with the evidence and the support of that plan so that your plan is going to be understood and well accepted. And with that, I'm going to now go to the demonstration piece. Okay, so here's the home page. And the first place that we'll want to go is we're going to want to go and look at the answer. And here we see the spending program rolling out over the next, looks like about 25 or 30 years. And we see this based upon total spending by year. Now, underneath each one of those bars is a set of assets, a set of cable segments that comprise it. We can look at that from a total perspective, or we can look at it broken down by cable type, or, and maybe most interestingly, we can look at it based upon intervention strategy. So we can see replace versus inject. Let me just make this a little bit larger so that it's a little easier to see. And here I can go out and grab, a couple of years worth of information and focus in directly on that. And you'll see that in, let's say, 2037, right? We'll further focus that. And I'll just reduce the size. Oops. Excuse me. And now I've got it looks like 6 assets that are part of this spend in 2037. And you'll see it's a mixture of injection and replacement. And you can see that the age of the cables is different, and there's other characteristics associated with them. So we're going to take a look at one of them now and drill down and look at them from the perspective of that documentation that we talked about. So first, we can see the demographics associated with that cable. Which feeder it's associated with, the substation. We can see the type of cable. We can see its length, its phasing, and other attributes that are relevant to it. Here we've got information regarding the results of the model. So the age at intervention, the cost of intervention. We see whether the cable is considered injectable or not, and the costs associated with that. And then finally, we look at who the downstream customers are and what the risks are associated with that particular cable. If there's a failure, what's the impact going to be? So there's a set of documentation that really can provide all of the answers and could actually be used for somebody to take the model and trace it through on a pencil and paper basis if they so desired. So far I've covered the spending component and answering the question, the spending plan, and I've covered the second portion, which is Arrow for documentation purposes. And now the third piece is Arrow as a data discovery tool or as a decision support tool. So I'm going to go down to the decision support area, and I'm going to open up just one of my summary reports. And we're still focused in on those 5 or 6, on that one specific asset. So I'm now going to just kind of clear the slate, and now you get to see a histogram of all of the cable assets that I have based upon their age. And I think that will extend out a few years. And that's interesting, but there's a lot more interest in this information that we have. So I can click on what we call our filters page. Now here we see a lot of that information associated with all of the assets. And so I might look at my busiest substation from the perspective of the number of cable segments. All right, 168. If I were now to go back and look at my chart, you'll see that it reflects just those items. And now I'll go a little bit deeper and look at my busiest feeder. There's Riften Blind Cliff, and that's got 38 segments. And now I've further streamlined that analysis. And the reason that I'm doing this is because sometimes folks use this to look at and to package up multiple years worth of replacement or refurbishment activities if the economic cost is the loss of economic cost is less than, let's say, the cost of putting together the maintenance project to stand up teams to go out and to perform this analysis. So there you can see those are the 10 segments that are there, and this might be a good time to maybe go back and take a look at my asset register on my spending plan. And so I might look at these and say, well, I can package up these 3 years worth of replacement, and since I'm gonna fire up a project in the near term, this will allow me to generate those economies of scale, where I can then go out and take that, export it into a spreadsheet, and then provide that to my field force in terms of projects to work on. So in a nutshell, my demonstration today was to look at the spending plan, to look at the documentation capabilities, and then to look under the covers at the underlying data, all of its attributes, and just paint a picture of how you might perform some type of data discovery, hypothesis test, or decision support activities. And now I'm going to go back to the slide deck. and I'm going to talk about the future. So the industry continues to change, and the Arrow product will continue to change and evolve with it. Some of the things that we're doing right now are we're working with customers on integrating mapping capabilities directly into Arrow, and then allowing them to do visualization of circuits, as well as packaging and bundling. So you put those two features together, and now you can look at your circuits and look at your segments on a map, color coded by the year that they should be addressed, and then make decisions about packaging these activities. We're seeing Arrow turn into kind of the comprehensive asset register for your underground cable, and then because we have a long and stellar history in the area of benchmarking, and benchmarking is really quite important. We're going to integrate outage data and reliability data, and be able to provide benchmark analysis as to how well your cable program and activities are relative not just to individual circuits within your utility, but across like circuits at many utilities. So with that, I'm going to turn it over back to Chrissy so that we can start to maybe wrap things up and answer a few questions.
Thanks, Kevin. I'll hand it back over to myself here. And if you haven't already entered a question into the chat window, you're welcome to do so at this time. But I'll go through the questions and see if we can answer some of these for you. Our first one comes in from Anthony, and he asks, how does the model determine which year a segment should be addressed?
Hey, so Darren, why don't you take that in? Why don't you take that question?
Yeah, so good question. The model is performing an economic optimization. So it's looking at the trade-off between, you've got two incentives on your hands. On the one hand, you want to wait as long as you can to spend your money, keep it in the bank or spend it on other things and get benefit from it. So that's one incentive. But the longer you wait, the more likely your cable is going to be to fail. And so there's this increasing stream of risk. So in general, there'll be this kind of U-shaped curve of total cost with a minimum point out there someplace. If you can kind of picture that in your head, what we're trying to do is identify what is the minimum life cycle cost strategy for this cable, considering all the options that we've got available. And that strategy will suggest a timing of intervention.
Great, thank you, Darren. Our next question comes in and asks, how does the 40-year warranty work?
I'll be glad to take that, Chrissy. This is Chris. Well, when our Novinium teams come in and rejuvenate a cable, typically what they do is they pop open a transformer or the transformers at either end of the segment. We'll rejuvenate that cable and we'll affix a warranty tag. The warranty tag has got information about the cable that we've rejuvenated, and in the unlikely event that there is a failure, which would necessitate a warranty claim, you just go to our web-based tool and enter the warranty claim tag number, and we'll process a refund for that sub-segment that we had rejuvenated. And I'll say again that we have a 32-year track record, so we have extremely good data about the reliability of cable rejuvenation, and our failure rate is less than 0.5% across all that cable that we've rejuvenated. So it's a very good warranty process. Our customers tend to really love it, and I hope that answers your question.
Thanks, Chris. Our next question comes in from Greg, and he asks, will there be any GIS integration with your software?
Well, sure. This is Kevin. Greg, thanks for that question. So yes, we as part of our mapping capabilities, we will take your GIS longitude, latitude, your whole network layout, and that will become part of the tool, And so your networks will be, your circuits will be visible, and it'll be fully integrated into GIS.
Thanks, Kevin. Our next question asks, is there a limit on the number of cable segments that can be evaluated?
Okay, great. Well, I'll take that one again. So the underlying approach that we've taken in terms of building this tool is to be able to handle, I'm going to call it a virtually unlimited number of cable segments. We've already tested it with hundreds of thousands of segments and into the low millions, and we still get the same type of performance that that you've seen, and the database is more than capable of handling that. So we've designed it to really handle the largest systems.
Great, thank you. We have another question that asks, how long does it take to start a rejuvenation project?
Chrissy, I'm glad to take this. It's Chris. Well, we have lineman crews across North America and the US and Canada. And so if you have a cable rejuvenation project that you want to get started, really the first step would be to engage one of our regional sales managers. You can find their contact information on our website, or you could send a chat to Chrissy and we'd be glad to connect you with a regional sales manager. Depending on the scope of your project, we could get started in a couple months. It's not unreasonable. If you have maps or an area identified, we can help you to scope that out and share with you our work rules and our safety process, and get started really in a couple months.
Thank you, Chris. Another question coming in asks, how does the tool support scoping and executing actual projects beyond establishing an overall budget?
So the way that the tool helps to do that is through that decision support capability that I showed before, where we take geographies of the various cable segments and allow you to look at the let's say all of the segments that fall within a particular map area or concentric map areas, and then be able to make decisions about items that are planned for this year, and items that are planned for next year, and items maybe that are planned for 3 years out, and be able to then make a judgment analysis as to whether I want to expand this current year's project to include other cable segments that might not have originally been planned for the next year or two. But certainly you would not want to bring in something that's 10 or 15 years out based upon its remaining economic life. So the decision support capability supports that. And that's an area where we're actually going to be growing things using our mapping and visualization capabilities.
Great. Thank you so much, Kevin. We have time for one more question. So I'm going to ask this one. It asks, what has been the reaction of regulators or boards to this approach?
I think that's one that I can answer. This is Darren. So there have been many utilities that have used this approach specifically for cable for internal purposes. So they've used it as a way of explaining to themselves what their cable program ought to look like and how they ought to prioritize cable rejuvenation against other spending. So that's been very successful in internal terms, talking to executives and rate-making groups and so forth. Particularly in Canada, where the rate-making process is much more aggressive, and the regulators dive in a lot more detail into what kind of spending is going on and challenge individual projects and so forth. This approach has also been used there very successfully to make a case for why spending on cable rejuvenation is needed and why it makes the customers better off. So I would say that the track record in front of these non-technical stakeholders and outside groups has been very good.
All right. Thank you so much, Darren and Kevin, for taking the time to speak with us today. And thanks to everyone for joining us. If we did not get to a particular question that you may have had, we're happy to get in touch with you after the webinar to go over those individually and address those questions with you. And we hope you enjoyed your webinar today. All right, thank you so much.